I'm not sure if I'd talk to you about the little book of differentiation, like a little golden book that I pinched the idea of and put together just a few things about differentiation. But differentiation is about the rate of change, and because the gradient measures the rate of change, and differentiation gives us an expression for the gradient, and we'll talk more about that in our applications in the physical world when we do that chapter. And we've learnt to differentiate polynomial functions. They're just x squareds, x cubes, etc. We haven't done this one, and when I put this together, like I've been saying in previous videos, that we did the order of chapters slightly differently. We are looking currently at the derivative of the log function, and yet to do both of these really, the derivative of trig functions. Things that belong to all types of derivatives are the rules that you must follow, no matter what the function is, are the product rule. So the product rule is like an overriding rule. The quotient rule, same, and, whoops, I'm not sure why it does that, and the function of a function rule. So we've already seen function of a function with regards logs, and you saw how that needed to be followed. What I'm going to do now is cover a couple of situations where you'll have to follow the product rule or the quotient rule, and you'll see that the log function is involved in these examples. So a bit of quick revision about the product rule. When our y, or our entire function, is made up of u times a v, then we do u v dash plus v u dash. Quotient rule being v u dash minus u v dash all over v squared, and v must be the function that's in the denominator of the quotient. Okay, notice that now we've got a situation where either u or v involve a log. So here, y is equal to x cubed, it's times in here, log of x to base e. Now, for those of you that may realise now that you didn't learn the product rule very well before, you're going to get some more practice at it. And I would like to see you setting it out really precisely this time. We know from past experience that the students who set their solutions out like this are far more likely to get the answer correct. I'm not saying that you can't do it other ways, but following this method you're far more likely to end up with the correct answer. So I can see that I've got a little function called x cubed, which I've chosen to call u, and to get u dash, I'm just going to differentiate that. So bring the power to the front, subtract 1 from the power, not too difficult. The other function that y is made up of is log to base e of x, and we know that v dash is 1 over x. Now, what we know that we can do, and the reason why we set it up like this, is we're going to join these two. So we form a cross, because y dash, and the question says find y dash, is u v dash plus v u dash. And this is my first connection, u to v dash, so it's x cubed times 1 on x plus v, which is log to base e of x, times u dash is 3x squared. So we would do our simplifying here because we can, and get x squared plus, we bring that 3x squared to the front and we multiply it by log to base e of x. Don't assume that 3x squared gets sort of sucked in here to the log function. No, it doesn't. It doesn't belong in the log function. It's log of x to base e only. And what have we got? We've got a common factor, so we will take that out and we'll end up with a 1 plus 3 times log to base e of x, which you can see over here. So some overall rules that you really would do well to add to a summary are, keep in mind that even within logs, you could need to use the product or the quotient rule, or function of a function rule. Function of a function. Keep that in mind. If you've got y is equal to log of x to base a, now this is something other than what I was saying our rule addresses. You must have it firmly understood that the rule is for differentiating a log is only when the log is to base e. So if we don't have an expression where we've got log to base e, then you'll need to use the change of base rule. And you know, when you do change of base rule, that you have the option of putting any base, you will definitely make the base be e. So you, in a way, you won't have a choice. Otherwise, you won't be able to differentiate. And as you can probably appreciate, you will have set up using change of base rule, you'll set up a quotient, because that's what the change of base rule looks like, and then you'll need to use the quotient rule. So there's a lot involved in one of those, but if you take it slowly and logically, you can get through it. When you've found the derivative, what have you found? Well, that doesn't change. The derivative, when you've found f dash x, you have an expression for the gradient along the graph of y. So whatever y is, you have, if you differentiate it, you have an expression for the gradient. And just as previously, you would know that to find the value of the gradient at a particular point, you must substitute, otherwise it stays an expression, the x value of the point into your gradient expression. And if you will need the actual gradient when finding the equation of a tangent, or the gradient and equation of the normal. So they're the common questions that lead on from just straight out differentiating. A point of inflection occurs when the second derivative is naught and concavity changes. That's not going to change either. So they are some basic overriding rules. I think I'll stop the video there and talk about these next examples in another video.